The origin of the Infant Incubator project stems from research in the fall 2019. The research outcomes recognized that high infant mortality rates occurred in economically disadvantaged areas of the world, largely in sub-Saharan Africa. This started the goal of combating rising economic and health inequalities through technological design with a low-cost, low-power solution. Current incubators in the market range from $5,000 to $25,000. The project goal of Infant Incubator is to keep materials, electronics, and mechanical architecture all within $1,000. This has led to multiple iterations and improvements of the Infant Incubator each year. The team is currently working on improving the fourth prototype and currently in works to develop a fifth prototype next year, with an emphasis on partnering with foundations in sub-Saharan Africa to implement the design in a future setting.
The housing team is responsible for designing and building the incubator's body. This includes collaborating with other sub-teams to implement their parts into the whole system and eventually testing the system functionality. Currently, the team is focused on the Prototype 5 housing redesign, which is entirely focused on manufacturability. The idea is that the product will be shipped ready to assemble with minimal tools. The team replaced the previous solid plastic tubes with hollow ones to allow for lighter incubator and easier wire management, as wires can be fed through them. They also implemented three-way corner pieces that allow the manufacturer to easily fix all degrees of freedom. This created a more level and square product. The French door model in Prototype 4 was replaced with an oven door to allow easier access to the baby for healthcare providers. The heating compartment was changed to have fans at 45 degrees that circulate air more effectively, creating a better temperature regulation and a more efficient use of the heater.
The control system regulates the environment inside the incubator and monitors the infant's vitals through an STM32 microcontroller. Until this year, the incubator system operated using an Arduino Teensy 4.1. However, this Teensy is about double the price of our STM board. This decision was made to align with iChoose's goal to provide low-cost and low-power solutions. With this, one major milestone this year has been rewriting all the Arduino code into C to be compatible with the STM development environment. This microcontroller connects to an alarm system, 3 sensors, and an LCD screen that displays the output of 4 variables: temperature, humidity, infant temperature, and infant heart rate. Another milestone the team achieved that improved the project's accessibility was our user interface UI redesign. This redesign features both a larger screen and 3D printed labeled buttons. The next steps for the controls team are to design a PCB that interfaces with the sensors and UI, as well as develop standards testing procedures for the incubator.
The Vital sub-team is focused on accurately measuring the infant's core temperature and heart rate. The team's primary objective is to select, calibrate, and integrate reliable sensors into the incubator system, along with developing a safe and effective device to hold the sensors onto the infant. The team is currently conducting more in-depth testing on both sensors and the attachment device. The testing includes evaluating sensor accuracy as well as practicality and comfort. The sub-team has gone through several different prototypes of the attachment device to optimize its design for its use, ensuring secure contact and minimal interference with the infant and care provider.
The humidifier system was redesigned this past year to improve the misting duration while still maintaining a proper internal humidity level within the enclosure. First, we reimagined what the humidifier's casing could look like. We determined that the duration of use needed to last an entire workday, which is about 8 hours. When creating the new casing, we found that it would be most efficient if the unit that holds the water could be removed to be refilled and cleaned regularly to meet specific compliant and medical standards. For the casing to be removed, the system itself had to be non-weight bearing on the incubator's internal enclosure. The circuit in the humidity system needed to be adjusted to include fail-safes and electrical components to prevent independent failures in compliance with general safety electrical standards. The team is focused on providing adequate humidity and temperature, heating and cooling. With the circuit, we are currently looking at integrating an incubator heating mechanism such that the heat can turn on and off with the humidity system via an STM control module, which is in collaboration with the control subteam. The next steps for the environmental system are to add alert lights for low water indications and temperature regulation modules. Once the circuit is successfully implemented into the entirety of the system, specific neonatal environmental standards will be tested to ensure compliance.
The business team was recently integrated into the Innovative Global Solutions Enterprise with the goal of securing foundation partnerships to obtain funding for our organization, as well as identifying potential field testing sites in sub-Saharan Africa for the Infant Incubator. The team works closely with the enterprise advisor, Dr. Manser, in the Foundation's office, gaining valuable experience in grant writing and community outreach. This semester, we conducted in-depth research on various foundations, evaluating their requirements and determining which organizations best align with the project's mission. Based on this work, letters of inquiry, grant proposals, and project information packets were drafted to help convey our designs to potential partners in the field. Down the line, we expect to see a final feasibility analysis of our device, as well as a market entry strategy for manufacturing.
Thank you to all that have helped to support the Infant Incubator project, and a huge thank you to our advisor, Dr. Manser, and to our sponsor, Plexus, especially Nathan Tetzloff and Lindsay Hooker for their time and generous support in the continuation of the project.